Welcome to today's Explainer. We're doing something a little different today. We're taking some top-tier European automotive engineering insights and translating them so we can all learn something more. Because let's face it, when most people think about an electric vehicle, they just picture a giant battery hooked up to a big motor. But an EV is so much more than that. It's a highly advanced, high-tech ecosystem where energy management is absolutely everything. Today, we are going to expose the hidden tech that is really powering EVs.
Here's our roadmap for today. We'll uncover the hidden EV directors, define maximum quality, check out the gold standard cars on the road right now, and finally, dive into the Tesla nuance.
All right, part 1. The hidden EV directors, the secret ecosystem under the hood.
So first up, we have the inverter. Think of this as the muscle and the mind of the whole operation. You see, the battery stores its energy as direct current, or DC, but the electric motor needs alternating current, or AC, to actually spin. The inverter is the translator making that happen, and it also works in reverse when you hit the regenerative brakes. But it's not just passively passing power along, it's actively managing these massive, explosive power flows in literal fractions of a second. By tweaking the frequency and amplitude of the electrical wave, the inverter precisely dictates the motor's torque and speed.
Next on the list is the DC-DC converter. Now, this component solves a problem you've probably never even thought about. Your main traction battery operates at wild, incredibly high voltages. We're talking 400 or 800 volts. But stuff like your headlights, your windshield wipers, the infotainment screen, all those safety sensors, they all still run on a classic 12-volt network. This transformer safely steps down that massive high voltage to power your everyday onboard systems. It provides something called galvanic isolation, which basically guarantees your everyday accessories work flawlessly without dangerous high-voltage spikes frying your electronics. The absolute best versions today use top-tier 3-in-1 integration to save weight, and they're liquid-cooled so you never experience voltage drops, even if you crank up every single accessory at once.
And the third director is the BMS, or Battery Management System. Think of this as the brain guardian. It is constantly keeping tabs on the exact voltage, temperature, and current of every single individual cell tucked inside that massive battery pack. It calculates exactly how much juice you have left and the overall health of the battery over time. But most importantly, this system is your absolute ultimate safety net. If you ever get into an accident, the BMS is the thing that instantly cuts the high voltage to guarantee thermal safety and prevent fires.
Moving right along to part 2, defining maximum quality, upgrading to the gold standard.
Up until pretty recently, EVs relied on older silicon, specifically IGBT semiconductors, for their inverters. But the industry is shifting, and it's shifting fast. Premium vehicles are completely abandoning that old silicon for silicon carbide or gallium nitride chips. These new chips are just incredibly compact, and they handle high power with vastly superior efficiency.
And this number perfectly illustrates the impact. 70%. By switching over to silicon carbide chips, automakers are reducing energy loss in the form of heat by up to 70%. That pushes the total energy efficiency of a top-tier inverter to a staggering 98 to 99%. For you, the driver behind the wheel, that translates directly to a 5 to 10% bump in your total driving range, literally just from swapping out the silicon.
When you're evaluating a high-end battery management system, the real secret sauce lies in how it balances the cells. Cheaper economy systems use what's called passive balancing, which means they literally waste the excess energy of highly charged cells by just burning it off as heat. Talk about inefficient, right? But active balancing is a total game changer. It acts like a highly intelligent smart network, physically transferring power from the most charged cells directly to the less charged ones. This creates perfect harmony across the entire pack and drastically prolongs the battery's overall lifespan.
Another massive leap in quality is the WBMS, or Wireless Battery Management System. Introduced by giants like General Motors with their Ultium platform, and developed by folks like Analog Devices. This tech uses radio frequencies instead of physical cables to talk between battery modules. By ditching the physical wires, the WBMS saves some critical weight and completely eliminates the #1 failure point, cable wear and tear. Plus, it lets manufacturers pack even more energy cells into the exact same physical space. On top of all that, the best software now uses predictive artificial intelligence to actually monitor chemical degradation and stop thermal runaway hours before it could ever even happen.
Now, you might be totally surprised to learn that car brands rarely build these chips and boards from scratch themselves. They actually rely on specialized Tier 1 suppliers. For inverters, heavyweights like Bosch, Marelli, and ST Microelectronics deliver the silicon carbide chips at 800 volts. For the DC-DC converter, companies like Delta Electronics, Denso, and Valeo provide that super high-density 3-in-1 integration. And for the BMS, leaders like Analog Devices, Texas Instruments, and CATL are pioneering the wireless and AI active balancing tech. When you combine these three things, 800 volts, silicon carbide, and active balancing, you get what we like to call the holy trinity of EV tech.
Okay, Section 3, the gold standard cars, real-world applications of the Holy Trinity.
First up, we have to talk about the Hyundai-Kia group. Honestly, they were the very first to truly democratize this technology. They pulled it down from millionaire hypercars and exclusive prototypes right into accessible premium passenger vehicles. Their eGMP platform natively adopts the 800-volt architecture, it uses silicon carbide inverters from the specialists, and it features a highly advanced BMS across the Hyundai Ioniq 5 and 6, the Kia EV6 and EV9, and the Genesis GV60.
And because of all that, they hit an absolutely incredible benchmark, 18. Thanks to the flawless synergy of that 800-volt architecture and active thermal management from the BMS, these eGMP cars can charge from 10 to 80% in an unbelievable 18 minutes. It's seriously impressive.
Moving over to the performance sector, Porsche and Audi are really pushing the boundaries. Porsche pioneered the 800-volt system with the Taycan, and now their newly co-developed premium platform electric used on the new Porsche Macan Electric and Audi Q6 e-tron pushes silicon carbide efficiency even further. Their advanced BMS actively balances the cells so that incredible rapid charging speeds of up to 320 kilowatts, combined with those sudden sporty bursts of track power, don't ruin the battery's chemistry.
Then there's Lucid Motors, often considered the absolute queen of efficiency. Founded by the former chief engineer of the Tesla Model S, Lucid has achieved the highest power density in the world, pushing well past 900 volts. They produce this completely in-house unit called the Wonder Box. It's wild. They've managed to cram their silicon carbide inverter into an enclosure roughly the size of a carry-on suitcase. This ultra-precise proprietary active balancing is exactly what allows the Lucid Air to achieve over 800 kilometers of real-world range.
Meanwhile, Chinese tech giants and Geely brands are aggressively adopting this exact high-voltage, silicon carbide-driven architecture. You'll find it powering the entire Polestar lineup, Lotus's stunning hyper-SUVs like the Elantra and Emeya, BYD's e-Platform 3.0 on the Seal, and even tech giant Xiaomi's highly popular SU7 Max sedan with its lightning-fast hypercharge system.
Which brings us to part 4, the Tesla nuance. What about the Pioneer?
I know you've probably been wondering, but wait, what about Tesla? Let's dive right into this because it is a fascinating piece of industry strategy. Tesla actually pioneered the use of silicon carbide inverters way back in 2018 with the Model 3, and their battery management system software, it's widely considered legendary, perhaps the best on the entire market for cell balancing.
But here's the catch. Despite having the best BMS and pioneering those silicon carbide chips, Elon Musk has strategically kept their mainstream passenger cars at 400 volts. Why? Well, it mostly comes down to industrial cost efficiency and keeping seamless compatibility with their massive existing global supercharger network.
So if you want the full, uncompromising, gold standard trinity in a Tesla today, we're talking the silicon carbide, the legendary active balancing BMS, and the ultra-fast 800-volt architecture, you have to look exclusively at the Cybertruck. Right now, it's the only model in their entire lineup boasting the complete package.
This rapid evolution just proves that the EV race is really won deep inside the silicon. The innovation curve here is absolutely vertical, making the transition to these 800-volt and silicon carbide architectures the definitive new baseline for the entire automotive industry moving forward.
By translating all this dense technical jargon into plain English, you now know exactly what separates a good electric car from a masterclass in modern engineering. Keep this holy trinity in mind the next time you're looking at a spec sheet. Thank you so much for joining me today for this explainer to look past the hype and hopefully learn something more. But before you go, as 800-volt architecture and silicon carbide become the standard rather than the exception, it leaves us with one massive question. What unseen breakthrough will revolutionize the electric vehicle next?